All right. Excuse me. All right, so the product rule. And quotient rule. All right. I guess let me write down the rules first. So you have the formulas. Oh, let me pull it up. Here we go. This is the one I like. So if your function, so here's a product rule. So if y of x is equal to a product of two functions, and f and g are differentiable, then righty, the derivative of y of x is equal to, I think the easiest way to write it is with quotes. The derivative of the first one times the second plus the derivative of the second part times the first. Similarly, quotient rule. I want to write all that stuff again, but the derivative, if y of x is equal to f of x over g of x, let me shorten it, and g of x is not 0, then the derivative of y of x is equal to, this is the one I always forget, it's going to be derivative of the first times the second minus derivative of the second times the first over the g function squared. So whatever g is, you square it. G of prime minus g prime f. Yeah, that's right. Okay. So we're going to use these formulas. And the reason I mean, number one, you can kind of see that, well, I don't really need it because you could multiply this out and then take the derivative of every single term, right? But eventually you get to weird functions like this, number two, where you can't get away with from the product. It's just going to be there. Also, if these two functions here were like super high power, then you wouldn't want to expand that. Like if this was x squared minus 8x to the seventh power, multiplying that out would be stupid. And you'd have like tons and tons of terms. So product rule would be best. And then eventually we have a quotient. The only other way to do this would be to use the limit rule, the first one we did, or force this into a product rule, um, which we're not going to do yet, but quotient is going to be best for this kind of stuff. This one here. Anyway, so let's do the first one. I'm going to rename it though. So use a product rule to find, rewrite the question dy dx. It's an ugly D, whatever. So here's y of x. I'm renaming it on purpose. That way we can use the F and G notation above. In the homework, they named it G. So I'm like, well, I can't call it two different things, G of X. So this is F of X. This is G of X. So the derivative of y or dy dx would be, formula says, derivative of the first part times the second part plus the derivative of the second part times the first part. So what I recommend is just write them on the side here, just to keep yourself organized. And you can just plug it in, right? So there's f. So the derivative, what's the derivative of f here? What do you guys think? What's the derivative of x squared plus 3? Yeah, it's just going to be 2x, right? And g prime is going to be what? It's similar, right? Yeah, so just plug it in, you're pretty much done. So dy dx is equal to 2x times g plus g prime times f. Is it clear how we got there? So then at this point, we're pretty much done. Just got to multiply it out. Um, Sadly, we have to do algebra. All right, so 2x times x squared, 2x times negative 8. 2x squared times that garbage. 2x times 3. 8 times that stuff gets me here. Add your like terms. We get what? 2 plus 2x cubed. Negative 16 plus 8. It's minus 8. Oh, wait, hold on. I missed something. Let me double check something. This should be minus 4. Let's see. I'm just looking at the answer. I don't see how they got negative 24. So I must have done something weird. F prime G times G prime F. Yeah, I don't see a mistake. Do you guys? Hmm. Negative 16 plus 8 is 8. Negative 8 plus 6x plus 24. So it looks like I have a sign error somewhere. Oh, here it is. God damn it. Um, this should be minus. Sorry about that. Always those little sign errors, man. That should be minus. There we go. Everything's great. Minus 24 plus 6x minus 24. There we go. Any questions on this problem? Good. I'm gonna move on to the next one. Next one won't be as bad because just signing or either the x and cosine. You guys cool on this page? All right. Let me know. Number 2, find y prime, shorten this up, given y of x equal to damn it. That's weird. So again, this is a product. So if I say that my Um, I'll write this first. We'll say f is 3e to the x. Derivative will be something. G will be cosine. G prime will be something. All right, so what is f prime? Hey, remember, derivative e dx will not change. So it'll just be itself. That 3 doesn't do anything. Do y'all remember the derivative of cosine?
Negative sign x.
Yeah, it's going to be negative sine. So we got everything we need. Just plug it in. So f prime times g plus g prime, which is the negative sign you guys said, times f. So nothing we can do anymore. We can factor 3ex, I guess, if you want. But that's it. Any questions on these two examples? Product rule, pretty straightforward. Okay, move on then. So let's do a quotient. So the derivative for a quotient is going to be f prime g minus g prime f over g of x squared. So remember that f is the numerator, g is the denominator, so just find those parts and put them together. Derivative of x, no big deal, right? Derivative of this will be 4x cubed. And that's it. Plug it all in. We will get 1 times g minus g prime times f. over g squared. That's it. Make it a little pretty. This will be uh, x to the fourth plus 7 minus 4 x to the fourth over x to the fourth plus 7 squared, which is simply negative 3x4 plus 7. This is that's as pretty as it's going to get. Okay. Any questions on the formula and the derivative steps or the algebra? Okay.
Pretty straightforward.
Yeah, it's not too bad, right? Just keep your formula straight in your algebra and should be okay. I think the hardest part is the algebra stuff, honestly. All right. We'll move on then. Okay, so that's pretty much the first four questions. It's just that over and over again. It changed a little bit here. Do you see what they're asking? I don't think it's worth doing, but we can.
You add the 0 after you find the derivative.
Yeah, yeah, exactly. Got it. Does everyone else see what you're supposed to do?
For question number 5, correct?
Yeah. Well, both of them are
Yes.
the same thing, but yeah, it's 5. So find your derivative. Once you find it, plug in 0 and then write down the number. That is it. So that'll be the, do you know what that graphically what that means? What that 10,
No.
negative 10 represents? Remember we said the derivative gives you slopes, right? At a particular point.
Yes.
So if you graph f and then you go to 0 and draw a tangent line, the slope would be negative 10. So it's all the same stuff, right? It's just the slope at c. It's just the derivative is a little more involved. So do a product rule, plug in 0. Over here, do a quotient rule, plug in pi over 6. And you'll just use your unit circle and you'll have some numbers. Number 9. Number 8, I'm not gonna, it's up to you. It says without quotient rule. Um, oh, actually, yeah. Do you see what they're saying or how this could be much easier without it? Do y'all see another way to do that problem? Okay. What if I rewrote it like this? Do you see that quotient rule is not necessary? So before you do quotient, try check and see like, oh, can I rewrite it first? Because quotient can be annoying. You could do quotient on this and it will work out. But if you rewrite it, you see how this is just a power rule? So it's just do the power rule and that's it. You're done. Of course, they like the variable at the bottom, no negative exponents. All right, let's move on then. I'm assuming there's no questions and it makes sense, right? Okay. You see how um, this problem, you can rewrite it and avoid doing the quotient rule, just like we did before. Except this time, you can divide these x's. X3 halves divided by x. This will reduce to 3x to the 1/2. And then you just do a power rule again. So don't jump straight to the quotient rule. Just think about it first. Because if I can avoid doing quotient rule, I will. Because I don't want to do a lot of work. This guy over here, I don't see a way out of it. Power rule was the very first one. Let me write it down for you. Oh, it was this one. I'm sure you'll remember when you see it. If y is x to the n, the derivative is nx n minus 1. Number 10 and I do not see a way out of the quotient rule. Just got to do it. And 11. Hmm. Let's do 11 because there's a lot of algebra. So I feel like you should see it. Just in case you're rusty. I need another page for that. Okay, so find the derivative. So first, let's rewrite it. I think distributing this x cubed and combining it into one fraction would be better. So what I'm going to do is first combine it and then multiply. I feel like you'll see that better. So 1 minus this as one fraction would be x plus 6 over x plus 6 minus 5 over x plus 6. So add them together and get to here. So now I'll go ahead and distribute the x cubed. That would be x to the fourth plus x cubed. So you can use algebra to make it a little prettier. I mean, you could do quotient rule or product rule straight up, and then during the product, you'd have to do a quotient. So then that would be a pain, but if you combine everything, it's a little easier. Is there any questions on the algebra that we did? Does it make sense?
I know how you got x to the fourth. How'd you get the x to the third in the numerator?
Well, we got to multiply both parts by x cubed. So x cubed times x cubed times 1.
Oh, okay. Never mind. Sorry.
But the rest made sense?
Yeah, yeah, that was good. Everything's good.
Cool. So at this point, take your derivative. So derivative of the first part times the second part minus derivative of the bottom part times the second part. This time I just went and did everything at once. I didn't write the derivatives. I should have, but I did not. So derivative of this part will be 4x cubed plus 3x squared minus 1 derivative of this part is just the 1. Square the bottom part. And now we're almost done. Yeah, we're gonna have to do. Well, the homework is cool. Well, everything has an x squared, right? And I feel like that might be confusing. Yeah, let's just multiply. Let's not get weird. There we go. Combine like terms, and we'll get 4 minus 1, 3 minus 1, oops, plus 24. So it should be 26. There we go. Finally, they both have an export in common. The homework decided to leave it like this. This is as good as gonna get. Any question on the algebra? Is that okay?
Where did you get the 4x third?
4x third. Let's see. This one?
Yes.
Okay, so when you do the power rule in this piece right here, this term, it'll turn into 4x cubed. Derivative of this should be 3x squared. Doing the power rule on each part, each term separately, gets you this.
Oh, okay, I see that now. Thank you.
Yeah, no worries. Okay. Oh, we did on the X plus 6. Well, the derivative of constants is 0, so that's gone. Derivative of x, if you do the power rule, you'll end up with a 1. Because if you have bring down the 1, right? 1 minus 1 would be next to the 0. So this piece right here is a 1 plus 0. So 1. All right. You guys have any questions on uh, quotient rule or product rule? Does it seem doable? Because it's the homework is going to repeat itself over and over again. Um, All right, then we can stop here then, I guess. I can leave some time for homework next time. If we have enough time.